Hi, this video is shows you how to do the calculation for the water of crystallization. If you need to see the practical one, I put a practical one up that you need to look at. So what we're looking for is the number of moles of water in a crystal. So here we are, we have a crystal of copper sulfate, which is CuSO4.X H2O. Dot means water of crystallization. X is a number, and we need to find that number. So here we are, we've got the example. Find the water of crystallization if 25 grams of hydrated copper sulfate, which is the formula I've written above, is heated to leave 16 grams of dry copper sulfate. So we do it in the same way as we would do a empirical formula. So first, step one, list dry copper sulfate and water. So CuSO4, which is the dry one, and water. So we've separated them. List the masses of copper sulfate and water. Now, if you look at the question, it tells you the mass of dry copper sulfate, so that's quite straightforward. So that's 16. But the mass of water we'll have to calculate, and that's the difference between the wet and the dry. So 25 minus 16 equals 9 grams, and that's the mass of water that was driven off when we heated it. Like I said earlier, check the video on how to do the practical. Then we need to find the number of moles. Moles equals mass over relative mass. So it's 16 over the relative mass of copper sulfate. And you check this from the periodic table, but it equals 160. So that's 64 for copper, 32 for sulfur, and 4 lots of 16, which is 160. And then there's 9 grams of water, and we divide that by 18. Hydrogen is 1, oxygen is 16. There's 2 hydrogens, so therefore it's 9 divided by 18. Okay, that gives us 2 sets of moles. The moles of copper sulfate is 0.1, and the moles of water is 0.5. Now, once again, we need to find the simplest ratio. And to do that, we divide by the smallest. 0.1 is the smallest, so we take 0.1 and divide it by 0.1. Gives us 1. And then we take 0.5 and divide it by 0.1. And if you do it in the calculator, that gives you 5. So we've got a ratio of copper sulfate to water, which is 1 to 5. And that tells us that the X we were looking at earlier is equal to 5. But we've got to put that into the equation. So we wrote CuSO4.X H2O, but it should be written as CuSO4 Sorry, it's just auto-corrected itself. CuSO4 dot 5 H2O, and that's a classic question, okay, and it's very much like empirical formula, getting the simplest ratio by dividing by the smallest. Here's a second example. We need to find the water of crystallization, and this time we're using magnesium sulfate. Okay, so magnesium sulfate is MgSO4. We need to list the dry magnesium sulfate and water, so we're making 2 columns. Then we need to put the mass of magnesium sulfate, the dry stuff, and it tells you you've got dry 6 grams, so we can put that in. And remember, the water is the difference between the wet magnesium sulfate and the dry magnesium sulfate. We've driven off all of that water whilst heating it. So we do 12.3 to minus 6 equals 6.3, so that's our mass. Obviously, we now need to convert that into moles by dividing by the relative mass. Relative mass of magnesium sulfate using the periodic table would give you 120. Oops, and what have I done there? Okay, the relative mass of water is 18, so it's 6.3 divided by 18. Okay, that gives us 2 sets of moles. And the moles of magnesium sulfate is 0.05, and the moles of water, we do that on the calculator, is 0.35. I'm trying to keep them in nice, neat columns and not always succeeding, but those are the mole ratios. Now we need the simplest ratio, so we divide by the smallest. The smallest here is 0.05. So we take 0.05 divided by 0.05, gives us 1. And if we do 0.35 divided by 0.05, that gives us 7. And that's a much simpler ratio than we had before. So as before, we can now substitute that into the formula, and that should give us, here's the old formula, dot X H2O. X means it's loosely bonded, and we need to substitute our value of X, which we now know to be 7. So MgSO4 dot 7 H2O. You need to practice a few times, but it's a relatively straightforward calculation. Thanks very much.